Alright, in today's video we're going to finish the law of sines, so still 14.1, law of sines, but we're going to do something called the ambiguous case today. Okay, so that's going to be on page 121. There should be a code. Well, if it's not in this video, it was in the last one, but it looks like this. It's got this long, the ambiguous case of the law of sines. So we're going to work on that. I'm going to go ahead and glue this in right here on 121, and then we're going to get started on it. But glue it in. I will tell you that you do have that state test at the end of the year. The ambiguous case, it's more than likely not going to be on there. That's not normally something that you have a question about, but it is something that you do need to learn. So go ahead and get glue this in. Let's get started on this example.
Then you can look at this and the example, but here's where you have two triangles in a minute. But we're going to work some of each. Which, like I said, in the ambiguous case, it's possible to have one triangle, no triangle, or two triangles. This breaks it down really well if you decide, hey, which one am I going to have? Alright, so, example 5. Given a triangle with a measure of A, which is 30, a side length 20, a side length of 16, we're supposed to find the other dimensions. So it says, use the law of sines to find the measure of B. So that's what we're going to do first. Now, I think they gave you this space right here to do that. I don't think that's enough room. So I'm going to find the measure of angle B down here. And I have to use the law of sines because I can't just subtract from 180 anymore. If you remember from just a second ago, the law of sines, we take, what is the only ones that we know both the angle measure and the side length? A, okay? So we're going to take A with the side length of 20. Over sine of its angle, what's the angle A, equals, do we know B? B is 16. Do we know B's angle? So we put sine of B. That is the only difference in what we just did. We figure out what we don't know. We don't know the angle B. We are still going to cross multiply. We're going to have 16 sine of 30 equals 20 times sine of B. Again, it's not different yet. How do I get everything away from sine of B? Divide by 20. So 16 sine 30 over 20 equals sine of B. Do you remember what the inverse operation of sine of B is? Sine what? Sine -1, which literally is sine inverse. B equals, type this in, sine inverse, parentheses, it will give it to you when you say it. 16 sine of 30 over 20. Now, if I were you, I would type all that in at the same time. But if you do, you need to make a fraction on your calculator. Do you know how to do that? It's been a little while since you've had to. Do you remember what button to press to make a fraction? Alpha, stat plotter, alpha y equals 16 sine of 30 over 20. That guarantees you don't have that rounding error problem. We are going to round the angles to the nearest whole number. So you should have gotten 23.57, but what is that rounded to the nearest whole number? 24. If you did not get that, you need to make sure you have typed that in correctly. So I'm going to say the measure of angle B is about 24. Okay. So we're going to go up and fill this in. It says the measure of B, okay, we found that out, it's 24. If this has two possible triangles, the second option for angle B would be its supplement. Do you remember what supplement means? 180. What is 180 minus 24? Here's what this is trying to decide. It's saying this right here could be 24 or it could be 156. Now we got to think that through. So there would be nothing left for C. That means this one does not work. So wait, this does not make sense. The conclusion is there is only one triangle. So we don't even have to worry about the second one. It does not work. Because 156 plus 30 is over 180 to begin with. We don't even have extra room for C. So if this is actually 24, we can then move on. We can find the measure of angle C, and then later find side length C. They could have no answer, one answer like this 24, or two different answers. Because they can either make one triangle, or they could make two like this one did. Or it could be possible that it's like, you remember when we did the triangle inequalities and we said, hey, the side lengths could be this, this, or this? Well, it's possible that they're giving you something that's not a triangle anyway. So those are the options. Either it makes one, two, or no triangle. So this one makes one triangle. If the measure of angle B is 24 degrees, what is the measure of angle C? Or how do you find it? 106? Okay, how'd you find it though? Yeah, so 30 plus 24, which is, so that's not 106. I can't hear. Oh, okay. And I can't add or look at things either. Thank you, guys. 24, not 25. So it's 54, which is 126. We should all make sure that I know what I'm doing at this point. Okay, 126 degrees. Okay. What is the only thing still missing from this triangle? Side C. I need to do that just like I did a second ago, like earlier on the last foldable. So side C. I'm still going to use 20 over sine of 30 equals, what? We don't know C. What is C's angle measure? So C, you have to find the angle measures before. Alright, now somebody remind me how to do that. Cross multiply. So 20 sine 126 equals C sine 30. Then what'd you do? Type this in. 4 decimals on the sides. Yep. What'd you get? Point what? I think on your homework it tells you, so whatever it tells you go with, but otherwise, round the angles to the nearest whole, sides to 10,000. Alright, example 6. Like I said, there are a whole lot of these ambiguous case examples, but in the real world where you're solving these problems, not in the real world, but even in the world of mathematics when you're solving these problems, you don't see this ambiguous case that much. Okay. Example 6. Use the law of sines to find the measure of angle B. We're going to do exactly what we did just a second ago. Measure of angle B. What do we already know from this triangle, no matter what? We know angle A and the side A. So what do we set up? Equals. We're looking for 16 over sine of B. Then what do you do? So 16 sine of 30 equals 7 times sine of B. Does it matter if those are written in the other order? No, I don't know why I do it that way. Okay, now what? Divide by 7. So 16 sine of 30 over 7 equals sine of B. Then what? You guys aren't completely familiar with that yet. It's not multiply it by. It's okay if you said that. But it's take the inverse sine of, which is. Okay, then type that in. Somebody tell me what you get. Oh, okay. It says error. Well, did you know some of you just skip through the error? It'll tell you what's wrong. You know, the domain error it go to. It has something to do with the fact that this side length is now short. Look at the one that we had right up there. We also had 30 and 16, but our A was longer. That means whatever is going to be left for C, this is not going to be a triangle that's possible. Since this says error, there is no triangle possible. We need to stop there. We can't do anything else. What did you say? Yeah, it's like undefined. So, the example 5 is where you have 1. Example 6 is where you have none. If you had to guess, what's example 7? We're going to have 2. Okay? We're always going to start these by finding a missing angle. There is an actual rule where you can look at the triangle and see, based on what the side lengths are, whether you're going to have 1, 2, or none. I always find it easier just to find the measure of the missing angle and then determine from there, but there is a way. I can talk about that later in a few minutes. Alright, the measure of angle B. What are we going to set up again? The A is 10 over sine of 30, they haven't changed that yet, equals 16, haven't changed that either, over sine of B. It's not different. Cross multiply. 10 sine of B equals 16 sine of 30. What are we going to divide by? Sine of B is equal to 16 sine of 30 over 10. What do we do to find B? The inverse, sine inverse. Alright, somebody tell me what that is. 53 degrees. Since we have an answer, we need to see what the second one would be. Do you remember how we found out what the second one was? 180 minus 53. 127. Is it possible to have an angle measure of 127 and 30 in the same triangle? Okay. Then we have to do both. Here's what I mean by that. we are going to have to find the measure of angle C with this, the measure of angle C with this, the missing side length with this, and this. We're going to focus on this one first. Measure of angle C is just 53 plus 30, and then subtract that from 180. 53 plus 30 is 83, minus 180 leaves 97. Okay, how do you find side length C? Okay. I'm going to give you a minute to finish that. Before you finish that, what would be measure of angle C if B is 127? It's what? 23. So how would you find side length C if measure of angle C is 23? Yeah, the only difference is sine of 23. I want you to finish solving both of those. It is like doing two problems in one if it just so happens that the second B makes sense. You should have cross multiplied. What did you get for C when the measure of angle C was 97 degrees? 8509. Okay. How about C when the measure of angle C was 23 degrees? So this problem is the only one, and you'll probably only have one in your homework, where if it makes sense for this obtuse angle to be in that triangle, you will have to have two problems, which means on the worksheet I'm about to give you, you'll probably have to have an attached piece of paper.